Hello everyone, this is Shubham Chaudhary and I welcome you again in the 27th video of our YouTube channel. Today is 27th of January and we are discussing this LeetCode hard problem. Problem number 629, K inverse pairs array. So here there is an integer array nums and an inverse pair is a pair of integers ij such that ij lies from 0 to nums.length and nums of I is greater than nums of j. So it will be called as inverse pair, and we are given two integers n and k. We need to return the number of different arrays consist of numbers from 1 to n such that there are exactly k inverse pairs. Since the answer can be used, we need to return it in modulo of 10 raised to power n plus 7. So what is the inverse pair first of all? So let's suppose this is the array and these are the values of array. So an inverse pair is a pair of integers such that the I and j should lie in the index of that range and nums of I should be greater than nums of j. So here let these 2 and 3 we will check for 2 and 3. I and j lies in the range and nums of I which is 2 and nums of j which is 3. So nums of I is smaller than nums of j. So this is not the inverse pair. If we replace these two, if we swap these two, then nums of I is greater than nums of j. So this is a inverse pair. Okay. If we replace 3 here, 3, then 1, then 2, then 4. Here we will get different number of inverse pairs. First for 3 and 1 it will be a inverse pair as nums of I is greater than nums of j. After that this 3 and this 2, so nums of I, then 3 and 2 will be the another pair that will also be an inverse pair. Then for 1 and 2, this not possible, 2 and 4 not possible, so here we will return 2 as there will be two inverse pairs. So we need to find how many arrays can we form such that with the given numbers n equals to 3 and k equals to 0. If k equals to 0, we need to find number of permutations of arrays with inverse pairs as 0. And in this example, let suppose size is 3, array size is 3 and inverse pair count is 1. So we need to return the number of permutations of arrays such that their inverse pair should be 1. So let's discuss here the example 1. If here size is 3 and the inverse pair equals to 0, so we need to return uh, array permutations whose inverse pair should be equal to 0. So in the only the array 1 2 3 which consists of numbers from 1 to 3 has exactly 0 inverse pairs. Now our array will contain from element 1 to n. For n equals to 3, so 1 2 3 will be there, and another permutations will be there like 2 1 3 3 2 1 3 1 2. But in that we need to count only 0 inverse pairs. So there will be one array and we will return 1. In the second example, array size is 3 and inverse pair count is 1. So the permutations of array, in the permutations of array, these two array 1 3 2 and 2 1 3 have exactly one inverse pair. Here this pair will be an inverse pair and here this pair will be an inverse pair. So we will return the number of arrays. So we will return 2. This is a hard problem, and if you don't get it, please watch the video again. let's discuss the approach here. So in this problem we will use dynamic programming. So you need to have a strong foundation in dynamic programming to solve to understand this type of problem. First of all, we will create a DP array of size n plus 1 cross k plus 1. So for the example, DP n equals to 3 and k equals to 2. We will create a DP of size 4 as 4 cross 3. So here we will take n as rows and k as columns. So from 0 index to 2 and from 0 index to 3. Now we will iterate through the array and add a nested for loop for adding all the previous row elements. We will discuss what is the approach in the code. So let's just check. We will iterate through the array and we will add a nested for loop for adding all the previous row elements. So here basically these are the first base cases for whenever we want the inverse pairs we as 0, we will return 1 because uh, whenever the inverse pairs is count is 0, we will return all the elements in the ascending order, and this will be only unique array in the permutations of all the arrays, and we will get only one array for k equals to 0. So for k equals to 0, we will assign it equals to 1, and whenever the array is equals to 0, array size equals to 0, we will return 0 to all the k's. So this will be the base conditions. Now for dp of ij, here dp of 1 0, we will add the previous dp value with other values. That values will be dependent on the I. So for this dp of 1 comma 0, we will add dp of I minus 1 and j minus x. Here we will add dp of I minus 1 and j minus x, where x will be the range according to the I values. So for I, it will be here we will add for the I equals to 1, we will add only one element which is above it. So dp of ij is 0 earlier, then we will add 1 to it. According to that, same for this position. First of all, there was 0 here, then we will add up above 0 to it, so it will become 0 and 0 here also. Now this is the interesting one. This iteration is the interesting one. Here we will add two numbers we will add the numbers according to the I values. So for 2, we will add about about two positions, such 1 and 0, this, but we will not add this one, this position. We will add this position and before this position. So I mean to say index for k equals to 0, so we will add k equals to 0 and k equals to minus 1 for this position. So our formula will be for dp of I minus 1 and j minus 1, means j equals to 0 and j equals to minus 1. So we will add these two numbers here. Again for this position, dp of 2 comma 1, we will add 0 and 1 here. So 0 and 1, we will get 1. What will be here, what will the value here we will discuss. Then for the next number dp of 2 comma 2, we will add this dp and this position. So 0 plus 0, and we will get 0. So here, as the k value is negative, so we will return 0. So 0 plus 1, if it will be equal to 1. Now here, for I equals to 3, we will add 3 numbers. So 0 dp of I minus 1, and this k equals to 0 index, then dp of I minus 1 and k equals to minus 1 index, and minus 2 index. So we will add these 3 values here. So we will get 1, as we will add 0, 0 for, we will return 0 for k equals to my negative numbers. Then for dp of 3 comma 1, we will add this value plus this value and the negative value. So we will get 2 here, and for this value we will get add dp of 0, then dp this 1 and this 1 value. So we will get 2 here at last. Now we will return this dp of n comma k, where n is 3 and k is 2. So our final output will be 2 for this example dp of 3 comma 2. And here, talking about this nested for loop, we are using this nested for loop for adding these numbers, for adding all these 3 numbers for this position. Then for this position we will add these 2 numbers. So for that we are using this nested for loop, and we will check this condition, j minus 1, j minus x greater than equal to 0, where x is the number of times we need to calculate the values, and this condition should be greater than equal to 0 for our positions not to go out of the bound. So for j equals to negative values, we will return 0, or we will not count for that values. Simply we will add only these values. So let's code for this solution. Before that, if you are new to the channel, hit the like button and subscribe for more content. So we will create a mod const int 10 raised to power 9 plus 7. After that, we will create a dp vector of vector int dp with size n plus 1 and value vector of int. Size will be n plus 1 cross k plus 1 with value 0. Now we will initialize dp of 0 comma 0 as 1, because if k equals to 0, it will always return 1. This will be the base condition. Then we will iterate through this dp array. For that, we will start from int I equals to 1, I less than equal to n, I plus plus, and for int j equals to 0, j less than equal to k, and j plus plus. Now here we will add a nested for loop. Okay, shit. Now here we will add a nested for loop for adding all the previous row elements. So for this position we will add these 3 values. For that we will use the for loop with some conditions. The for loop will be for int x equals to 0, and x should be less than equal to minimum of j and I minus 1. We are applying this condition such that our index should not go out of the bound and we should not calculate for negative values, and we will use this condition j minus x greater than equal to 0 for only calculating the positive and 0 value 0 index elements, and not to calculate the when j is negative. So we will apply the formula dp of ij will be equal to, we will add dp of ij to dp of I minus 1, and here we will add j minus x, and we will take mod of this so that our value should not go out of the bound. Here we are using j minus x, and this loop will iterate and calculate all the values such that for this position that loop will calculate all these values. If the position is this, then it will calculate for these two values and it will skip for the negative value. So we are applying these conditions if j minus 6 greater than equal to 0 and this minimum condition. After this we will return dp of n and k, the last position. This last position we will return, it will give us the value answer. Okay, that's the code. Let's run this code. Yeah, we are passing the test cases. Let's submit the code and check for the hidden test cases. Yeah, the code ran successfully. Here you will see we are getting this much of time complexity as we are using this for loop and third for loop, because the time complexity here will be big O of n into k into x, where x will be where x value will be dependent on this I. So we will get the time complexity here big O of n square into k, and the space complexity will be big O of n into k, as we are using this 2D vector. We can further reduce this time complexity by removing this for loop, and instead of using this for loop we can use sliding window technique, but that will be more complex for now. So I have discussed this solution. So that's it. If you enjoyed the video or found it helpful, don't forget to hit the like button and subscribe for more content. Stay tuned for upcoming LeetCode problem of the day videos and exciting month-stack web development projects. Happy coding, and let's make this year a fantastic one together. Thank you.